For each cloud service scenario listed below the table, drag it to the appropriate boxes in the correct match column to match it against its service type in the option column. Lift and shift migration of on-premises resources, development framework for custom applications, PaaS, analytics or business intelligence tools, PaaS, testing and development environments with full control, IaaS. Now let's go ahead and explain each of these answers. Starting with lift and shift migration of on-premises resources, this is best matched with infrastructure as a service, or IaaS. This is because IaaS gives you control over virtual machines and storage, allowing you to replicate on-premises infrastructure in the cloud with minimal changes. Next, development framework for custom applications fits platform as a service, or PaaS. That's because PaaS provides a pre-built platform that developers can use to build and deploy apps quickly without managing the underlying infrastructure. Moving on, analytics or business intelligence tools also aligns with PaaS. These tools are typically offered as ready-to-use platforms where users can run analytics, create dashboards, and extract insights without worrying about server management. Finally, testing and development environments with full control corresponds to IaaS. In these environments, developers need flexibility to configure and manage resources, which IaaS supports fully. Each match reflects the level of control and type of service needed for the scenario. Determine if the following statements are true or false. The public cloud is built, controlled, and maintained by a third-party cloud provider. True. Private clouds provide less control compared to public clouds. False. A hybrid cloud uses both public and private clouds. True. Azure Arc is solely for managing resources in a public cloud environment. False. Now let's go ahead and break down why each of these answers is correct. First, the statement that the public cloud is managed by a third-party provider is absolutely true. Public cloud platforms like Microsoft Azure, AWS, and Google Cloud are operated by external companies that deliver services over the internet, helping organizations avoid the cost of managing their own infrastructure. On the other hand, saying private clouds provide less control is false. In reality, private clouds are hosted either on-premises or in a dedicated environment, giving the organization full control over security settings, configurations, and compliance measures. Now, a hybrid cloud indeed combines both public and private cloud components. This setup allows businesses to balance scalability with control. For instance, they may store sensitive data in the private cloud while leveraging the public cloud for less critical workloads. Lastly, the claim that Azure Arc is only for public cloud management is false. Azure Arc extends Azure services across on-premises, multi-cloud, and hybrid environments. It provides a unified management platform, making it a versatile tool for modern cloud strategies. All these answers reflect core cloud concepts that you're likely to encounter on the AZ-900 exam. For each statement below, indicate whether the answer is true or false. A private cloud is always hosted on premises. False. A public cloud allows organizations to have complete control over security. False. A hybrid cloud combines both public and private clouds in an interconnected environment. True. A multi-cloud environment involves using services from multiple public cloud providers. True. Now let's go through each one and explain why these answers are correct. To begin with, the idea that a private cloud is always hosted on premises is false. A private cloud can be on-prem, but it can also be hosted externally in a dedicated facility, such as a third-party data center. The key factor is that it is used exclusively by one organization, regardless of location. Next, the statement that public cloud offers complete control over security is also false. In a public cloud, the cloud provider is responsible for much of the infrastructure's security, meaning organizations have limited control over security configurations compared to private environments. Now, the hybrid cloud scenario is correctly marked as true. A hybrid cloud merges private and public clouds, allowing organizations to run sensitive tasks in a private cloud while using the public cloud for scalable workloads. This gives both flexibility and enhanced control. Finally, the multi-cloud environment statement is also true. Multi-cloud means using services from more than one cloud provider. For example, running some workloads on Azure and others on AWS to avoid vendor lock-in or to meet specific performance needs. This question clearly helps reinforce distinctions between cloud types and deployment models. For each statement below, indicate whether the answer is true or false. IaaS provides more user control compared to platform as a service (PaaS). True IaaS users do not have to manage storage or networking configurations. False. Software as a service (SaaS) requires users to manage operating system updates. Unlike IaaS, false IaaS is best suited for organizations that need complete control over their cloud environment. True. Let's now walk through each answer and explain the reasoning behind them. To start with, IaaS providing more control than PaaS is true. With infrastructure as a service, users get access to virtual machines and are responsible for configuring the OS, apps, and security. In contrast, PaaS abstracts most of those layers to streamline development. However, the idea that IaaS users don't manage storage or networking is false. In IaaS, you're responsible for managing virtual networks, IP configurations, and storage provisioning, which offers flexibility but also requires more expertise. Next, the statement that SaaS users must handle OS updates is false. In SaaS, the provider handles everything from hardware to applications, including updates and maintenance. But in IaaS, users must manage those aspects themselves, which is a key difference. Lastly, it's true that IaaS is best suited for full control. This model is perfect for IT administrators or developers who need to define the system from the ground up. For instance, building a custom enterprise environment or migrating legacy apps without restrictions. These distinctions are crucial when choosing the right cloud model for your organization. Fill in the blanks by selecting the correct options from the drop-down menus. Cloud computing is the practice of using remote data centers to store and process data instead of relying on on-premises infrastructure. Now let's take a moment to explain this in detail. To begin with, remote data centers refer to facilities run by cloud providers like Microsoft Azure or AWS, where your data and applications are hosted and managed. Instead of installing physical servers in your office, you access powerful resources over the internet. Meanwhile, on-premises infrastructure is what traditional IT setups use. Organizations buy, install, and manage their own servers on site, which means more maintenance, higher upfront costs, and limited scalability. Cloud computing shifts all of this by moving storage, processing, and applications off-site, enabling businesses to scale easily and pay only for what they use. Think of it like renting space in a high-tech building rather than building your own. This shift to cloud models has completely transformed how modern organizations operate. A company is experiencing a large spike in website traffic due to a marketing campaign, causing their website to slow down. They need to quickly address the issue without over-provisioning resources long term. What cloud feature would best address this problem? Select one answer. A. Vertical scaling. B. Horizontal scaling. C. High availability. D. Load balancing. Let's now go over the correct answer and explain why it's the best choice. The correct answer is horizontal scaling. This cloud feature allows the company to add more virtual machines or containers to handle increased traffic. It's ideal for situations where demand spikes suddenly, like during a marketing campaign, and lets you scale out quickly without committing to long-term infrastructure investments. On the other hand, vertical scaling means upgrading an existing machine with more CPU or RAM. While helpful, it's limited by hardware constraints and not as flexible or fast as horizontal scaling in cloud environments. Next, high availability is more about ensuring systems are always up and running, not specifically about scaling with traffic. It supports uptime but doesn't solve traffic bottlenecks directly. Lastly, load balancing helps distribute traffic across servers but doesn't automatically scale infrastructure when demand rises. It works well in combination with scaling, but isn't a complete solution by itself. So in a real-world cloud deployment, horizontal scaling is your go-to strategy for handling sudden traffic surges without wasting resources. If a service with a 99% SLA is unavailable for 1.5 hours in a week due to maintenance, how does this impact the SLA? Select two answers. B. The SLA will not be breached because 1.5 hours of downtime is cumulative over multiple incidents. D. The service remains within the SLA limit as it allows up to 1.6 hours of downtime per week. Let's take a moment to explain why these are the correct answers. I don't think 99% SLA means the service can be unavailable for up to 1% of the time in a given period. In a week, that's about 1.68 hours, or roughly 1.6 hours when rounded for simplicity. So if the service is down for 1.5 hours, it's still within that allowed window, and therefore answer D is correct. Now, answer B is also correct because SLA downtime is cumulative, not incident specific. This means it doesn't matter whether the 1.5 hours came from one major outage or several smaller interruptions. As long as the total remains within the SLA limit, the agreement is still honored. On the other hand, answer A and C are incorrect because the SLA hasn't been breached, so the provider is not obligated to offer compensation or credits. The total downtime didn't exceed the 99% availability promise. In practice, this kind of question helps you understand how SLAs work in real-world scenarios, especially when calculating downtime allowances. Which of the following cloud models allows organizations to temporarily extend resources by using public cloud resources for short-term demand? Select one answer. A, public cloud. B, private cloud. C, hybrid cloud. D, multi-cloud. Now let's go ahead and explain why hybrid cloud is the correct answer. A hybrid cloud is a cloud computing model that combines both public and private environments. It gives organizations the flexibility to keep sensitive workloads in their private cloud while using the public cloud for temporary demand, like during a product launch or seasonal sales spike. This mix allows them to scale efficiently without overcommitting resources. In contrast, the public cloud refers to services offered by third-party providers over the internet. While it's scalable, it doesn't integrate with private environments by default, so it lacks that hybrid flexibility. The private cloud is used solely by one organization and is ideal for high security or compliance workloads, but it doesn't extend into the public space for temporary demands. Finally, multi-cloud involves using more than one public cloud provider, like AWS and Azure together, but it doesn't integrate private infrastructure, which is key for temporary extension with control. So in real-world use, hybrid cloud gives you the best of both worlds, scalability and security, all in one flexible model. Why is it important to familiarize yourself with Azure SLAs before designing a business-critical application? Select two answers. A, to ensure the application's availability aligns with the business's uptime requirements. B, to ensure the application is guaranteed 100% availability at no extra cost. C, to understand the potential costs associated with highly available services. D, to ensure the application uses physical infrastructure that matches the SLA. Let's go ahead and explain why A and C are the right answers. First, understanding Azure SLAs is essential to align the application's availability with your business goals. SLAs define the expected uptime for Azure services, whether it's 99.9%, 99.99%, or higher, and help you choose the right architecture to meet those uptime targets. If your app must be available 24/7, you need to know which services meet that level of reliability. Additionally, SLAs help you estimate potential costs. Higher availability often means using additional resources like multiple regions or instances, which naturally increases cost. By understanding SLAs, you can balance reliability with your budget before you build. On the other hand, option B is incorrect because Azure does not guarantee 100% uptime, and achieving high availability often comes with extra cost. Similarly, option D is also incorrect because in the cloud, you don't pick physical infrastructure. Azure handles that. You design around the service capabilities instead. So in real-world planning, being familiar with SLAs helps you build applications that are both reliable and cost-effective. For each virtualization type listed below the table, drag it to the appropriate box in the correct match column to match it against its description in the option column. Used for running applications in the cloud, virtual machine, VM, desktop virtualization service accessible from multiple devices, Azure Virtual Desktop AVD, requires the setup of OS and software maintenance, virtual machine. Allows multi-session Windows 10 or Windows 11, Azure Virtual Desktop AVD, provides infrastructure as a service, IaaS, virtual machine, VM. Now let's go ahead and walk through each answer and explain why it is correct. Starting with running applications in the cloud, this aligns with virtual machines. VMs give you full control over the operating system and environment, making them ideal for deploying apps without needing physical hardware. Next, when we talk about desktop virtualization that's accessible from multiple devices, we're referring to Azure Virtual Desktop. AVD allows users to connect to a Windows desktop from anywhere, providing a seamless experience across devices. Moving on, the need to set up and maintain the OS and software is a characteristic of VMs. Since you manage the virtual machine yourself, you're responsible for patching, updates, and software installations. Then, multi-session Windows 10 or 11 is a special feature. Unlike regular VMs, AVD supports multiple users connecting to a single Windows client session, which is great for organizations optimizing resources. Lastly, infrastructure as a service is the foundation of virtual machines. With IaaS, Microsoft provides the hardware and virtualization layer, but you control what runs on top, giving you the flexibility to build exactly what you need. So each match reflects the key strengths of either VMs or AVD based on their role in the Azure ecosystem. For each statement below, indicate whether the answer is true or false. Azure Virtual Networks support only one method of connecting to on-premises resources. False. Azure ExpressRoute provides a dedicated private connection to Azure, bypassing the internet. True. Point-to-site VPNs allow individual devices to securely connect to an Azure virtual network. True. Site-to-site VPNs require a VPN gateway device at the on-premises location to connect to Azure. True. Let's now break it down and explain each answer clearly. First, saying Azure Virtual Networks support only one method of connection is false. In reality, Azure offers multiple options, including point-to-site VPNs, site-to-site VPNs, and ExpressRoute. This gives organizations the flexibility to choose what fits their scenario best. Now, ExpressRoute is correctly marked true because it establishes a private, dedicated connection that bypasses the public internet. This results in lower latency, higher reliability, and better security, ideal for mission-critical workloads. Next, point-to-site VPNs are also a true option. These are designed for individual users, like remote employees, to securely connect from their personal devices into the Azure environment using an encrypted tunnel. Lastly, site-to-site VPNs are true as well, but they work differently. They connect entire on-premises networks to Azure, and then they require a VPN gateway device at the on-prem side to establish that secure link to Azure's VPN gateway. So, in real-life cloud architecture, these connectivity options are essential tools for hybrid cloud integration and secure remote access. Fill in the blanks by selecting the correct options from the drop-down menus. Azure Private Endpoints provide private access to Azure Managed Services over a private IP address, allowing secure connectivity without public exposure. Now let's explain each part so it makes complete sense. To begin with, the word private is key here because Azure Private Endpoints allow services like storage accounts or databases to be accessed securely without going over the public internet. This means your data stays within the trusted boundaries of your virtual network. Next, private IP address is selected because that's how the endpoint is accessed from within the same virtual network using an IP that's not exposed externally. It's assigned directly from your subnet. And finally, the phrase public exposure is exactly what these endpoints are designed to avoid. They eliminate the need for public-facing IPs or access, significantly reducing your security risks. In real-world terms, think of it like setting up a private backdoor to access a service instead of opening the front door to the entire internet. This is especially useful for organizations with strict compliance or security needs. For each Azure DNS and IP management option listed below the table, drag it to the appropriate box in the correct match column to match it against its purpose in the option column. Provides name resolution within Azure. Azure DNS allows resources in Azure to communicate within a virtual network. Private IP address assigns an internet-facing address for global reach. Public IP address translates domain names to IP addresses for public access. Domain name system DNS lets users configure custom domain names for Azure resources, custom DNS. connects private resources without internet exposure. Private IP address assigns a unique IP address for public-facing resources. Public IP address enables custom domain setup for Azure-hosted applications. Custom DNS. Now let's go ahead and explain each one in detail. We begin with Azure DNS, which is used internally in Azure to provide name resolution. This means it allows virtual machines and other services to find each other using names instead of IP addresses, all within the Azure network. Next, private IP address is used to let Azure resources talk to each other inside a virtual network. These addresses are not exposed to the public internet, making them perfect for internal communication and added security. Moving to public IP address, this assigns a globally routable IP to a resource, allowing it to be accessed over the internet, for example, a web app or a load balancer. Now, domain name system DNS is what translates friendly domain names like contoso.com into actual IP addresses, which browsers and apps use to connect to services. Then we have custom DNS, which allows users to define their own DNS settings or custom domain names for Azure-hosted services. This is often used to match brand domains or integrate with existing DNS systems. Private IP address appears again, correctly matched with connecting private resources without internet exposure. This ensures that even sensitive workloads can operate securely inside the virtual network. Public IP address is used again to assign unique public-facing IPs to resources that need to be accessed from the internet. And finally, custom DNS again helps with setting up branded or user-friendly domain names for your apps, which is essential for businesses looking to maintain a consistent identity. Together, these options form the foundation for networking and identity management in Azure, both internally and for internet-facing services. For each Azure subscription scenario listed below the table, drag it to the appropriate box in the correct match column to match it against the purpose in the option column. Separate departments for billing. Billing boundary. Apply policies at an organizational level. Access control boundary. Track costs by environment. Billing boundary. Manage access at a subscription level. Access control boundary. Distinguish development from production costs. Billing boundary. Now let's go through each answer and explain the reasons behind them. Starting with separate departments for billing, this falls under billing boundary. Subscriptions in Azure serve as billing units, so using different subscriptions for different departments helps track spending more precisely. Next, when you apply policies at an organizational level, that's considered an access control boundary. Azure uses management groups and role-based access control to enforce governance across departments or teams. Moving on, to track costs by environment, such as dev, test, or production, the best fit is again billing boundary. Using separate subscriptions helps isolate the cost of each environment, making it easier to manage budgets. When it comes to managing access at a subscription level, this is clearly an access control boundary function. Azure roles can be assigned at the subscription level, ensuring that users only have access to the resources they're authorized to manage. Finally, to distinguish development from production costs, again, billing boundary applies. Subscriptions help split and identify costs, making it easier to evaluate how much each environment consumes. This clear division of access and billing responsibilities makes Azure subscriptions a powerful tool for both cost management and governance. For each statement below, indicate whether the answer is true or false. The Microsoft Learn Sandbox provides a temporary Azure subscription for learning purposes. True. The sandbox allows users to create Azure resources at no cost while completing training modules. True. Users must manually delete all Azure resources they create in the sandbox. False. The Learn Sandbox is a required method for completing Azure learning exercises. False. Now, let's go ahead and explain each of these answers. First, the Microsoft Learn Sandbox does in fact provide a temporary Azure subscription. This is designed for learners to experiment and complete hands-on modules in a safe, isolated environment. Next, the sandbox is completely free to use while you're completing training modules. You can create real Azure resources without being charged, which is perfect for practice and certification prep. However, the idea that users must manually delete resources is false. The sandbox automatically cleans up everything you created once the exercise is completed or the sandbox expires, so there's no need for manual cleanup. Finally, while the Learn Sandbox is recommended, it is not required. Users can use their own personal Azure subscriptions to complete the same exercises, though doing so may incur costs depending on the services used. This setup makes Microsoft Learn both beginner-friendly and cost-effective for anyone exploring Azure. For each statement below, indicate whether it is true or false. Every blob container must have a globally unique name. False. By default, blobs inside a storage account are private and not publicly accessible. True. Each blob file has a unique URL that follows a structured format. True. Once a blob container is set to public access, it cannot be reverted to private. False. Let's now go through the explanations for each one. The first statement is false because blob container names only need to be unique within a storage account, not across all of Azure. You can use the same container name in multiple storage accounts without any issues. The second statement is true. When you create a blob in Azure Storage, it's private by default. You, as the owner, control access through shared access signatures, access policies, or role-based access control. The third statement is also true. Each blob has a structured URL that looks like this: https:/storagecountblob.core.windows.net/container/blob. This predictable format helps users and applications locate and access the blob easily. Finally, the fourth statement is false. You can change the access level of a blob container from public back to private at any time. This is often done to enhance security after data has been made temporarily accessible. So overall, understanding these access and naming rules is crucial when designing secure, manageable storage solutions in Azure. For each statement below, indicate whether the answer is true or false. The physical security layer focuses on securing software applications from cyber threats. False. The identity and access layer is responsible for authentication and controlling infrastructure access. True. The perimeter layer helps defend against distributed denial of service (DS) attacks. True. The application layer ensures applications are secure and free of vulnerabilities. True. Let's walk through each one to understand why. The first statement is false. The physical security layer is all about protecting physical assets, data centers, servers, and infrastructure from unauthorized physical access. Software security is not its responsibility. That's handled by the application layer. The second statement is true. The identity and access layer is responsible for authentication methods like single sign-on (SSO) and multi-factor authentication (MFA). It ensures that only authorized users gain access to systems and data. The third one is also true. The perimeter layer is your first line of defense in the network. It includes firewalls, DDoS protection, and network security groups that block harmful traffic from reaching your systems. And finally, the fourth statement is true. The application layer focuses on making sure your software is built to resist attacks. This includes secure coding practices, encryption, and ongoing vulnerability assessments. Understanding how each layer contributes to a defense-in-depth strategy is key to building secure cloud environments. For each statement below, indicate whether the answer is true or false. Zero Trust requires users and devices to be authenticated before accessing corporate resources. True. Organizations using Zero Trust should assume that internal and external networks are equally secure. False. Multi-factor authentication (MFA) is not necessary when implementing Zero Trust. While Zero Trust helps prevent lateral movement by enforcing access restrictions and segmentation. True. Let's go ahead and explain why these answers are correct. The first statement is true. One of the core principles of the Zero Trust model is verify explicitly, meaning every user and device must be authenticated and authorized before accessing any resource. Trust is never assumed. The second statement is false, because Zero Trust assumes that no network is inherently secure, not even internal ones. This means security checks are applied equally, regardless of whether access is coming from inside or outside the organization. The third is also false. Multi-factor authentication (MFA) is actually a critical part of Zero Trust. It adds another layer of verification beyond passwords, making it harder for attackers to gain access with stolen credentials. Lastly, the fourth statement is true. Zero Trust helps prevent lateral movement, where attackers move from one compromised system to another by enforcing least privilege access and segmentation, limiting how far any user or threat can go. Together, these principles form the foundation of a modern, secure enterprise access strategy. For each statement below, indicate whether the answer is true or false. Azure File Sync turns an on-premises Windows file server into a cache of Azure file shares. True. Azure File Sync only supports the SMB Server Message Block Protocol. False. Cloud tiering in Azure File Sync ensures that frequently accessed files are cached locally, while rarely accessed files remain in Azure. True Azure File Sync requires an internet connection, but does not depend on Windows Server. False. Now let's explain why these answers are correct. First, Azure File Sync does indeed turn a Windows server into a local cache for Azure File shares. This means that frequently used files stay accessible on premises while the full set of files is backed up in the cloud. It's ideal for hybrid storage setups. Next, the idea that Azure File Sync only supports SMB is incorrect. In fact, it supports multiple protocols, including SMB, NFS, and FTPS, giving organizations flexibility in how files are accessed. Moving on, the statement about cloud tiering is accurate. This feature ensures that files you access often stay cached locally, while older or rarely used files remain in Azure, saving on local storage space. Finally, the last statement is false because Azure File Sync does rely on Windows Server. It must be installed on a Windows Server machine to sync with Azure file shares properly. In summary, Azure File Sync enables a powerful hybrid file solution with local caching, protocol flexibility, and intelligent file tiering. Back. Can Azure virtual machines in different virtual networks communicate with each other by default? Select one answer. A. Yes, Azure VMs in different virtual networks can communicate without additional configuration. Incorrect. B. No. Communication between Azure VMs in different virtual networks requires setting up virtual network peering. Correct. C. Yes, if the virtual networks are in the same region. Incorrect. D. No. Communication is only possible within the same virtual network. Incorrect. Let's break this down and explain why the correct answer is B. By default, Azure VMs in different virtual networks are isolated from one another. That means they cannot communicate unless you specifically configure something to allow it. The most common method is called virtual network peering. This setup creates a low latency, high bandwidth connection between two virtual networks, almost like merging them without losing their individual identities. Now, option A is incorrect because virtual machines in separate networks won't talk to each other without that peering in place. Option C might sound logical, but being in the same region doesn't enable communication unless peering is still configured. Finally, option D is too restrictive. VMs can talk across different networks, just not by default. So the key takeaway is, if you want VMs in different virtual networks to communicate, you need to set up virtual network peering first. Arrange the steps for executing an Azure function in the correct order. 1. An event triggers the function. 2. The Azure function wakes up. 3. The function performs its task. 4. The function automatically scales based on demand, if required. 5. Resources are deallocated after execution is complete. Now let's explain this process step by step. Everything begins when an event occurs. This could be something like a new message arriving in a storage queue, a file being uploaded to Blob storage, or even a timer firing. This event triggers the function. Next, the Azure function wakes up. This is especially noticeable if it's in a consumption plan, where it's essentially asleep when idle to save costs. Cold starts can happen here. After waking up, the function performs its task. This is the actual code execution, like processing data, sending notifications, or interacting with other services. If there's a sudden spike in demand, Azure functions can automatically scale to handle more requests. This scaling is seamless and depends on the load and triggers. Finally, once the function has done its job, resources are deallocated. That means Azure cleans up the compute power it used, so you're not charged for idle time. So, Azure functions are efficient, event-driven, and cost-effective, ideal for handling background tasks, automation, and microservices. Establish the site-to-site connection using a shared key for authentication. 1. Create a virtual network in Azure. 2. Deploy a VPN gateway in a dedicated subnet of the virtual network. 3. Configure a VPN device on premises. 4. Establish the site-to-site connection using a shared key for authentication. Let's go ahead and explain how this works step by step. The process begins with creating a virtual network in Azure, which provides the address space and subnet structure needed for communication with your on-premises network. Next, you deploy a VPN gateway in a special subnet known as the gateway subnet. This gateway will be responsible for routing traffic between Azure and your on-prem environment. After that, you need to configure a VPN device on premises. This could be a hardware appliance or a software-based VPN solution that's compatible with Azure. It must be configured to connect to the Azure VPN gateway. Finally, you establish the site-to-site connection using a shared key, also called a pre-shared key. This key is used on both the Azure VPN gateway and the on-prem VPN device to authenticate and secure the tunnel. This setup ensures a secure and persistent tunnel between Azure and your local network, allowing seamless communication between your cloud and on-prem resources. A software development team is building a serverless API that performs calculations based on data submitted by users. They want the API to handle high traffic without managing infrastructure and want to keep costs low by paying only for the time the API is active. Which features of Azure Functions would be beneficial in this scenario? Select 3 answers. A. Pay-as-you-go pricing. B. Serverless scalability. C. Durable state management. Let's go ahead and explain why these are the correct choices. First of all, pay-as-you-go pricing means you're only charged when the function is actually running. This is perfect for scenarios with unpredictable usage patterns, such as APIs that get hit only when users send data. It helps teams minimize infrastructure costs without sacrificing performance. Next, serverless scalability is a major advantage. Azure Functions automatically scale out based on demand. If traffic spikes, the platform automatically spins up additional instances to handle the load. When demand drops, it scales back down, all without manual intervention. Finally, durable state management is useful when the API needs to remember what happened previously, such as in multi-step workflows. Azure Durable Functions allow you to manage this state seamlessly, so the function can pause and resume as needed. On the other hand, integrated operating system control is not needed here. Azure Functions are designed to abstract that level of control so you can focus purely on writing code without managing servers or OS configurations. So in summary, these 3 features, pay-as-you-go pricing, serverless scalability, and durable state management, make Azure Functions a powerful solution for serverless applications that need flexibility, resilience, and efficiency. For each statement below, indicate whether the answer is true or false. Route-based VPNs use IP routing to determine how traffic is encrypted and transmitted. True, policy-based VPNs dynamically route traffic between networks without static IP configurations. False, route-based VPNs are recommended for more complex topologies with multiple subnets. True VPN authentication in Azure is done using pre-shared keys. True. Now let me explain why these are the correct answers. Route-based VPNs are built on IP routing. This means they use routes to determine how traffic should be encrypted and sent across the tunnel. Instead of being tied to specific IP pairs like policy-based VPNs, route-based VPNs are more dynamic and flexible. In contrast, policy-based VPNs are not dynamic. They require static IP configurations, which define fixed rules for what traffic gets encrypted and sent through the tunnel. This makes them less scalable, especially in cloud environments. Route-based VPNs are generally the preferred option for complex topologies involving multiple subnets, hybrid scenarios, or dynamic route propagation. Their flexibility allows them to handle changes in scaling more effectively. Lastly, Azure VPNs use pre-shared keys, or PSKs, as a means of authenticating the VPN connection. These keys ensure that only trusted devices can establish the encrypted tunnel. So in summary, understanding how VPN types differ helps you choose the right configuration depending on the complexity and flexibility your network needs. When creating a container instance in Azure Container Instances ACI, which options are mandatory to specify? Choose 3 answers. A. Image source. B. Container name. C. Instance size. Let's go ahead and explain why these three are required. First, the image source is essential. This is the Docker image or the container image URL that defines what your container will run. Without it, Azure wouldn't know what code or service to deploy. Second, you must provide a unique container name. This is how Azure identifies and tracks your container instance. It's like giving your container an address so it can be managed and monitored properly. Third, instance size is required because it determines the amount of CPU and memory allocated to the container. Azure needs this to provision the correct compute resources for your workload. On the other hand, container description is purely optional. You can add one if you like for reference, but it's not required to launch the container. Similarly, VM size doesn't apply here because ACI abstracts away the underlying virtual machine. You only set the container's instance size, not the VM type. So to successfully deploy an ACI container, always remember, image source, container name, and instance size are the key mandatory fields. Which of the following redundancy options replicates your data within 3 availability zones in the primary region while also replicating it to a secondary region? Select one answer. A. Locally redundant storage, LRS. B. Zone redundant storage, ZRS. C. Geozone redundant storage, GZRS. D. Geo-redundant storage. Correct answer is C. Geozone redundant storage. Jesus. Now let's go ahead and explain why. Geozone redundant storage, or GZRS, is designed for both high availability and disaster recovery. It synchronously replicates your data across 3 availability zones within the primary region, which means your data remains available even if an entire zone goes down. Additionally, it replicates asynchronously to a secondary region, providing geo-redundancy in case the entire primary region becomes unavailable. On the other hand, locally redundant storage, or LRS, only stores your data in a single data center. It's the least durable option and doesn't protect against zone or regional failures. Zone redundant storage, or ZRS, spreads data across availability zones, but does not copy anything to a secondary region. So you get zone protection, but not regional backup. Geo-redundant storage, GRS, replicates data across regions, but only within one availability zone in each region, not multiple zones. So GZRS is the only option that offers both zone-level protection in the primary region and regional replication for disaster recovery. That's why it's the best choice for business-critical applications needing both high availability and geographic redundancy. You are tasked with ensuring that your company's resources comply with security best practices. You use Microsoft Defender for Cloud, and it detects that several resources are not configured according to security standards. How does Defender for Cloud help you address this issue? Select one answer. A. Defender for Cloud automatically resolves the issues without any input. B. Defender for Cloud provides a list of recommended actions based on Azure Security Benchmark. C. Defender for Cloud disables the affected resources until they are compliant. D. Defender for Cloud deletes any resource that doesn't meet the security standards. The correct answer is B. Defender for Cloud provides a list of recommended actions based on Azure Security Benchmark. Let me now explain why this is the correct answer. Microsoft Defender for Cloud acts as a security advisor rather than an automated fixer. It continuously assesses your cloud environment against the Azure Security Benchmark and flags any resources that are not aligned. Instead of taking action itself, it provides a prioritized list of recommendations. This gives you visibility into potential risks while allowing your team to decide how and when to remediate. Now, answer choice A is incorrect because Defender for Cloud does not resolve issues automatically. Human oversight is required to avoid disruptions. Similarly, option C is also incorrect. Disabling resources could affect critical services, and Defender doesn't take such aggressive steps. Lastly, deleting resources, as mentioned in option D, would be far too drastic and is not a function of this tool. Defender aims to support remediation, not enforce it by deletion. So the best choice and the most practical one is B, because it gives your security team the guidance they need without making irreversible decisions on your behalf. Your company is developing an internal web application and needs to choose between hosting it on Azure App Service or virtual machines. Which hosting solution should you choose based on the following requirements? Select one answer. Requirements. The development team does not want to manage OS patches and infrastructure. The application must scale automatically based on user demand. The application uses a widely supported programming language. A. Azure Virtual Machines. B. Azure App Service C. Containers on Azure Kubernetes Service, AKS. D. Azure Functions. The correct answer is B. Azure App Service. Why Azure App Service is the best fit for this scenario? First of all, Azure App Service is a fully managed platform designed for hosting web apps, RESTful APIs, and mobile backends. It abstracts away infrastructure concerns like OS updates and server management, allowing your developers to stay focused on the code. This perfectly aligns with the requirement that the team doesn't want to manage OS patches or infrastructure. Secondly, App Service offers built-in auto-scaling, meaning your application can handle increasing user demand without manual intervention. For example, if usage spikes during business hours, it can automatically scale out to accommodate the load, then scale back down during quiet periods. Moreover, App Service supports a variety of widely used programming languages such as .NET, Java, Python, and Node.js, so there's flexibility in development. On the other hand, Azure Virtual Machines would require your team to manage the entire OS layer, patching and scaling, which adds overhead. Containers on AKS offer orchestration and flexibility, but introduce complexity and infrastructure management, which your scenario wants to avoid. Azure Functions, while a great serverless option, are best for event-driven workloads rather than a full-featured persistent web app. So overall, Azure App Service strikes the right balance of simplicity, scalability, and language support, making it the clear choice here. Which two features are provided by Azure Active Directory domain services for legacy applications in Azure? Each correct answer presents a complete solution. A. NTLM and Kerberos authentication. B. Modern authentication protocols like OAuth and OpenID Connect. C. Group policy support. D. Built-in multi-factor authentication, FA. The correct answers are AM and Kerberos authentication and C. Group policy support. Now let's explain why these two answers are correct. First, NTLM and Kerberos authentication are core legacy protocols used for user authentication in traditional Windows environments. Azure AD Domain Services supports both of these protocols, which allows older applications that depend on them to continue functioning after being moved to Azure. This is especially useful when migrating legacy apps to the cloud without rewriting them. Second, group policy support is a feature that allows IT admins to manage users and computers using familiar policies, just like they would in an on-premises Active Directory. Azure AD Domain Services enables the application of group policy settings to manage things like user restrictions, software installations, and security settings across your virtual machines. On the other hand, Azure AD Domain Services does not support modern authentication protocols like OAuth or OpenID Connect. These are features of Entra ID, formerly Azure AD, which is used for newer cloud-native applications. Likewise, it does not include built-in multi-factor authentication. MFA is managed separately through Entra ID. So to summarize, for legacy applications that need classic authentication and centralized policy control, NTLM and Kerberos support, along with group policy settings, are the two key features provided by Azure AD Domain Services. Your company has an Azure subscription that contains resources in several regions. You need to ensure that administrators can only create resources in those regions. To do this, you need to create a new Azure policy. Using the provided image, identify where you should click to access the option to define a new policy. The correct area to click is Definitions, located under the Authoring section in the Azure Policy menu. Now let's explain why. To restrict administrators to specific regions, you need to create a custom policy definition. That's done under the Definitions section. This is where you specify conditions like allowed locations, define the parameters of the policy, and structure the logic that Azure will enforce. Although other sections like compliance or assignments are important in the policy lifecycle, they are not where a policy is created. Compliance shows results after a policy is assigned. Assignments lets you assign already defined policies, but since the task is to define a new policy, the correct and only place to start is definitions. This is where you author the rules that control resource behavior, making it the appropriate choice for this scenario. Fill in the blanks by selecting the correct options from the drop-down menus. The Service Trust Portal provides access to compliance-related documents and tools, helping organizations align with regulatory requirements. Now, let's explain. The Service Trust Portal is Microsoft's dedicated platform for transparency and regulatory compliance. It gives organizations access to compliance-related documents, such as audit reports, data protection certifications, and assessment guides. Additionally, it includes tools like the Compliance Manager, which help organizations assess and manage their compliance posture. So, by offering both documents and tools, the portal supports organizations in understanding and meeting regulatory requirements, making these two terms the correct choices to complete the sentence. For each passwordless authentication method listed below, drag it to the appropriate boxes in the correct match column to match it against its description in the option column. Uses biometric or PIN for login. Windows Hello requires a hardware device, FIDO2 security key. Sends a one-time passcode via SMS, SMS OTP, mobile app-based passwordless login. Microsoft Authenticator. Now let's go ahead and explain. Starting with Windows Hello, this method uses either facial recognition, fingerprint scans, or a PIN, making it a biometric-based passwordless authentication built directly into Windows devices. So when you log in using your face or a PIN on a Windows device, that's Windows Hello at work. Next, FIDO2 Security Key is a physical device you plug into your computer or use via NFC. It provides secure, hardware-backed authentication, making it ideal for high-assurance scenarios where phishing resistance is critical. Moving on to SMS OTP, this method delivers a one-time password to your mobile phone via SMS. While it's still used widely, it is considered less secure than modern alternatives because SMS can be intercepted or spoofed. Finally, Microsoft Authenticator is an app-based method that lets you approve logins with a single tap, removing the need for passwords. It combines security with convenience, especially for mobile-first users. All of these methods contribute to Microsoft's vision for a passwordless future by reducing reliance on traditional credentials. For each statement below, indicate whether the answer is true or false. External guest access provides visibility into guest activity. The correct answer is true. Enter external ID for partners manages user identities internally. The correct answer is false. Guest users cannot be assigned permissions to applications. The correct answer is false. External ID for customers requires users to create new accounts. The correct answer is false. Let's now go ahead and explain these one by one. To begin with, external guest access providing visibility into guest activity is true because administrators can monitor and manage what guests do within the environment. This helps enforce compliance and secure collaboration. On the other hand, enter external ID for partners managing identities internally is false. It's designed to manage external identities, such as those from other organizations or partners, not your internal employee directory. Next, saying that guest users cannot be assigned permissions is also false. In reality, guest users can be given specific access rights depending on their assigned roles, just like internal users. For instance, a partner could be granted read-only access to a project dashboard. Lastly, requiring customers to create new accounts with external ID for customers is false because users can sign in using existing social or enterprise credentials like Google or Facebook, which simplifies the user experience and lowers entry barriers. Each of these clarifies how Microsoft Entra supports flexible and secure external identity management. For each statement below, indicate whether the answer is true or false. Tags in Azure can help with cost allocation by grouping related resources. The correct answer is true. Resource tags are automatically inherited from the parent resource group. The correct answer is false. Tags can be used to enforce compliance with regulatory requirements. The correct answer is true. Tags can be managed through Azure PowerShell, Azure CLI, and the Azure portal. The correct answer is true. Now let me explain each of these in detail. First, tags in Azure are extremely useful for cost allocation. By tagging resources with values like project names or departments, organizations can group them and generate more meaningful billing reports. This is especially helpful in large environments with many services running simultaneously. However, tags are not automatically inherited from the parent resource group. This is a common misconception. You have to apply tags directly to each individual resource, which allows for more granular control but requires more effort during deployment. Furthermore, tags play an important role in regulatory compliance. For example, you can tag resources that store sensitive data to ensure they meet standards like ISO 27001, which helps during audits and policy enforcement. Finally, tags can be created and managed using several tools in Azure, including PowerShell, Azure CLI, Resource Manager templates, REST APIs, and the Azure portal itself. This flexibility allows both developers and admins to automate tagging as part of deployment pipelines or manage them manually when needed. A company is running workloads in multiple Azure regions and has noticed an increase in costs. The IT manager suspects that the cost difference is due to the deployment geography. What could explain the cost variation? Select one answer. The correct answer is A. Power and labor costs differ across regions. Let me now explain why this answer is correct and why the others are not. Azure pricing is influenced by the geographic location where services are deployed. This means that power, labor, and even local taxes can vary significantly between regions, and these factors directly impact the total cost of running your workloads. For example, deploying a virtual machine in the East US region may be cheaper than deploying the same VM in Japan East, simply because of the local infrastructure and utility costs. Now, while virtual machine configurations can definitely affect pricing, this question focuses specifically on geography, not configuration errors. So even though misconfigured VMs could lead to higher costs, that's not what we're being asked here. Similarly, storage redundancy options can influence cost, but that's more of a design decision than a geographic factor. And as for network traffic, it's not entirely free. Outbound data transfers usually incur costs, but this doesn't relate to the core geographic variation being asked about. So again, the most relevant reason for the cost differences across Azure regions is the variation in power and labor costs. Which feature of Azure Monitor allows you to set up automated responses when a performance threshold is breached? Select one answer. The correct answer is A, action groups. Now let's break this down and explain why. Action groups in Azure Monitor are specifically designed to trigger automated responses whenever a predefined performance threshold is breached. This means that when, for example, CPU usage spikes beyond 90%, Azure Monitor can send alerts, thus call webhooks, trigger Azure functions, or even scale out resources automatically, all through action groups. Meanwhile, log analytics is great for analyzing and querying collected log data, but it doesn't initiate any automated responses. It's more of an investigation and visualization tool. Azure Security Center, on the other hand, is focused on security posture management. It provides recommendations and detects potential vulnerabilities, but it doesn't take action automatically based on performance metrics. Application Insights is valuable for monitoring application performance, but like log analytics, it's more about observing and analyzing behavior rather than acting on it. So again, for automatic responses tied to monitoring thresholds, action groups is the tool you're looking for. An organization is close to reaching the maximum vCPU quota in its Azure subscription. What should the Azure Cloud Administrator do to resolve this issue? Select one answer. The correct answer is C. Request a vCPU quota increase from Azure support within the current subscription. Now let's explain why this is the best solution. When an Azure subscription approaches its vCPU quota limit, the proper and most efficient response is to request a quota increase from Azure support. Azure imposes default limits on resource usage to help manage capacity and prevent unexpected costs. However, these limits are not fixed and can be raised by submitting a support request that specifies how much additional vCPU capacity is needed. On the other hand, setting up a new Azure subscription just to distribute resources might seem like a workaround, but it adds complexity and doesn't directly solve the quota issue in the current subscription. Removing the existing subscription is not practical either. It would delete all resources and disrupt services. And while optimizing resource costs is important for budgeting, it has no effect on the actual vCPU quota limits set by Azure. Therefore, requesting a quota increase ensures business continuity with minimal disruption while staying within the current subscription structure. Which of the following scenarios correctly demonstrate the zero trust security model? Select two answers. The correct answers are A. A user must authenticate with multi-factor authentication (MFA) before accessing corporate resources. C. Conditional access policies ensure that only managed devices can access Microsoft 365 resources. Now let's go ahead and explain why these two choices reflect zero trust principles. First, requiring multi-factor authentication before granting access to corporate resources is a core component of zero trust. It reinforces the idea that no user should be trusted by default, even if they're inside the network. Instead, they must verify their identity through multiple factors, something they know, have, or are. For example, even after entering a password, users may be asked to approve a login via an authenticator app on their phone. Next, conditional access policies further enforce zero trust by checking whether the device attempting to access resources is compliant and properly managed. This ensures that even after identity verification, access isn't granted unless the device itself is trusted. So if a device is unregistered or has outdated security settings, access can be blocked or restricted. On the other hand, using a VPN to gain broad access doesn't align with zero trust, as it relies on perimeter-based security. Similarly, granting automatic access to any device connected to the network violates the principle of continuous verification. That's why only options A and C truly demonstrate the zero trust model in action. For each statement below, indicate whether the answer is true or false. The correct answers are: Azure Arc allows users to manage hybrid and multi-cloud environments using Azure tools. True. Azure Arc only works with virtual machines hosted in Azure. False. With Azure Arc, organizations can apply Azure policies and governance to non-Azure resources. True, Azure Arc supports Kubernetes clusters and SQL Server instances outside of Azure. True, now let's go ahead and break down why these answers are correct. First, Azure Arc enables centralized management across environments, which includes on-premises, hybrid, and multi-cloud setups. This means users can use familiar Azure tools to manage resources wherever they reside, not just within Azure. Next, the statement that Azure Arc only works with virtual machines hosted in Azure is incorrect. Azure Arc is built to support resources outside Azure as well, including virtual machines on other cloud providers, Kubernetes clusters, and even SQL servers running on-prem or in other clouds. Additionally, one of the powerful features of Azure Arc is the ability to enforce Azure policies and compliance rules on non-Azure resources. This allows organizations to extend their governance and security framework beyond Azure boundaries. Lastly, Azure Arc's support for Kubernetes clusters and SQL Server instances outside of Azure makes it highly versatile. For example, you can use Azure Monitor or Azure Policy on an on-prem Kubernetes cluster through Arc. So in summary, Azure Arc is designed for hybrid and multi-cloud flexibility, offering governance, compliance, and management across diverse environments. You need to configure access to Microsoft 365 resources for users in your organization. To group users for the assignment of permissions, which of the following options should you use? The correct answer is C, security group. Now let's explain why this is the right choice. Security groups are specifically designed for assigning permissions to users in environments like Microsoft 365 and Azure Active Directory. For example, if you want to allow a team access to SharePoint, Exchange, or Teams, you can place them all in a security group and grant that group the necessary permissions. This makes user management scalable and more secure. In contrast, Microsoft 365 groups are more collaboration-focused. They help teams share calendars, files, and conversations, but they aren't meant for security-related tasks like permission control. Resource groups are used in Azure, but their purpose is to organize resources like VMs or databases, not users. And finally, management groups help you manage access, policies, and compliance across multiple subscriptions, but again, not user-level access. So for managing who gets access to what in Microsoft 365, security groups are the way to go.